Let's start with the airframe. Thousands of specially formed, damage-resistant panels are riveted or otherwise attached to a lightweight underlying base called the airframe. The panels and frame together make a very strong, relatively lightweight craft. Many of these parts, especially the outer panels, are made from a carbon fiber reinforced material, though traditional aluminum and aluminum alloys are also used. Vertical frames underpin the cross-sectional tube shape, connected by longerons that stretch from nose to tail. And in between these, a vast network of stringers, intercostals, and subframes. At the nose, the radome shields a weather radar antenna beneath, while allowing specific radio frequencies to pass through for proper functioning. A double-layered bird strike barrier is situated behind that. Floor beams attach to frames and support the floor panels. Higher grade panels are used in high traffic areas and the cockpit or flight deck, with lower grade panels beneath passenger seating areas. Pressure bulkheads are reinforced metal barriers that separate pressurized from non-pressurized areas of the plane. Humans are accustomed to about 14 psi of air pressure. Passenger planes generally fly between 31 and 38,000 feet above sea level, where air pressure is a meager 4 psi or lower. As such, most sections of the airplane are pressurized while in flight. These areas include the flight deck and passenger areas, equipment bays, and cargo compartments. Unpressurized areas are the radome, landing gear bays, the center wing box, and the tail cone. The wings attach near the center of the aircraft. A center wing box ties wing frames together with the fuselage. The keel beam offers additional support. A wing-to-body fairing attaches to the keel beam and a pair of external longerons to enclose and further strengthen this critical wing attach point. Sturdy yet flexible spars stretch from the center wing box to the wing tip, one at the leading edge and one at the trailing edge of the wing. A pylon juts out from the wing frame to support the jet engine. Titanium links extend from the wing to the pylon, and tension bolts mate aluminum and titanium plates for an incredibly strong and flexible connection. Moving to the rear or aft of the plane, we see the vertical and horizontal stabilizers with their additional frame supports, and the tail cone, which houses the auxiliary power unit or APU. Windows. The windshields and side windows are made from 3 layers of chemically strengthened glass, covered with an anti-static coating. Cabin windows maintain the structural integrity of the fuselage with a thick outer pane made from acrylic. There's an additional protective acrylic pane on the passenger side with a hole and an air gap for pressure and temperature equalization. Doors. There are passenger doors front and rear, with corresponding service doors on the starboard side. Cargo access doors are also on the starboard underside. Smaller overwing emergency doors are located just above each wing. Doors must be disarmed before opening so the emergency slide will not deploy. An overpressure light, visible from the inside and outside the door, indicates whether the pressure differential would permit safe opening. A vent panel enables pressure equalization. Turning the interior latch handle allows the door to be opened. There's also an externally accessible door latch. The door rides on a hinge arm to swing out and away from the plane body, with stabilizer bars to guide its path. Wings and flight control surfaces. The wings generate lift for the aircraft. The main surfaces for flight control are the ailerons, elevators, and rudder. The ailerons generally function opposite one another to roll the plane. Elevators affect forward to back pitch, and the rudder controls yaw, or rotation around the vertical axis. The entire horizontal stabilizer, which the elevators are attached to, can be rotated to hold the plane at a particular attitude and leave the elevators for finer adjustments. To achieve this, the stabilizer is attached to a motorized device that can move up or down a threaded rod. Secondary flight control surfaces assist these primary systems. On the wing, leading edge slats and trailing edge flaps make up what is known as the high lift flight system. Both slats and flaps extend outward from the wing in a curved downward motion, which dramatically alters wing shape to allow for a much steeper climb angle, while also mitigating the chances of a stall for takeoff and while climbing to cruising altitude. The curved slat supports ride on gears driven by a line of connected shafts back to the slat power drive unit. For the flaps, a flap carriage rolls outwards driven by its actuator arm as the supporting flap track beam lowers. A row of multifunction spoilers is situated at the wing's trailing edge to assist the ailerons with roll control. Special ground spoilers near the fuselage operate in sync for a lift dumping effect, creating downforce during landing to effectively stick the plane to the runway, slow the plane down, and put weight on the wheels for wheel braking. Along the wingtip and winglet, there are static dischargers, which are flexible metal rods that discharge built-up static electricity that builds from friction as the plane travels through the air. Landing gear. A strengthened portion of the wing has attachments for the main landing gear, which is tucked inside the wing and body during flight. A hydraulic retraction actuator is attached to the main landing gear strut in such a way to rotate the gear into position for landing. Bearing doors pivot with the rotating action. When the landing gear is fully deployed, a hinged side brace and locking stay with its own actuator keep landing gear locked firmly in place. These components unlock and fold with the landing gear for stowing. The nitrogen and oil-filled struts also act as shock absorbers during landing, with an attached hydraulic shimmy damper to reduce shimmy or shaking that occurs while under extreme landing forces. There's a heavy-duty carbon brake stack in each wheel. Rotors match with keys on the inside of the wheel so they rotate together. Stators are keyed to the axle and are stationary. During braking, electrically driven pistons compress the stack, and the resulting friction slows the plane down. The nose landing gear has slightly smaller tires and brakes than the main landing gear and operates in a similar way with the addition of a rack and pinion steering system.